As we all know, Qwen 2.5 is very famous with a lot of different collections. I am currently interested in Qwen 2.5 VL, Vision Language Model, or multimodality. So I was checking this. The small version is VL2B instruct. So what I want to do is I wanted to do an image description. So I want to pass text and image, and I want the Qwen to describe that image. So this is about Qwen 2 VL 2 billion model instruct version. So this is the model architecture, and you can pass in the text, images and videos to this, and that will be encoded to the model, and the model will decode for you. Like, these are your inputs, and it might make new predictions from it. And how can you use it? So you need to have the latest transformer version in it. Just if you get this kind of error, that means you don't have the latest version. Make sure you install the latest version with this. Then there are vision language schedules from Qwen. Keep them, so they will be handy for processing your images and videos. That's it. Like, the basic pipeline of Hugging Face transformer goes like this. You need to import the Qwen for conditional generation and the tokenizer, and also, as I mentioned before, from the utils you need to get vision info processor. So model loading is very simple. So from this, get the pre-trained from the name of the model, and load the processor, then pass in the message. So it has the structure. So role, the user, content is image, the whatever type is image, and image is the image URL or image content, whatever. Type text, then describe this image. So this is my messages. So that needs to be converted to the chart template. So let's use processes chart template and apply over the messages, and that will be your input text. Then you have images as inputs or videos as inputs. You need to process them by the messages input, and you'll get images inputs and videos inputs. Then all of them together will be passed to the processor. The text, the images, the videos are passed to get the final inputs. So the inputs will be sent to the GPU and passed to the model to generate its predictions. So now we are setting it to max 128 tokens, and then so let's get the new generated IDs. So that's out IDs from the end of input ID's length. So you will get 128 output IDs. Then if we decode that, we'll get the output from it. So this is a basic pipeline that you want to get executed. But when I tried this on T4 GPU on Collab, I got some errors. So I made two observations initially. So these are my observations. On T4, when I tried the Qwen 2.1 model, so what I got is this. So first I tried the flash tension. So the T4 didn't support flash tension. It said Ampere GPUs are newer or supported, so maybe A100s or something else will do support. So T4 is not supporting, so that's one thing. Then I tried T4 without flash attention. Then I got into this out of memory error. So the model by default is taking around 5.38, and when you load the processor it will become 5.9 GB, and there is a PyTorch reserved about 420 MB. So there is only around 8.83 GB is free out of the 16 GB or 14.75 GB. No, and while you're trying to generate by passing inputs, it might require more than 12 GB. It's fluctuating, however, but so it's not sufficient. Then I had to try multiple variants from that point of view. Those are my explorations, how to resolve this problem and fit the model into consumer grade GPU and do inference on Qwen 2 using some images. That's my intention of doing it. So what I tried is on Kaggle there are multiple variants of GPUs, as you can see. Accelerator one is GPU P100, it's about 16 GB, and one GPU. And there is another GPU T4, but two GPUs, like 15 about 30 GB. So I have tried both, and I put together the code for single GPU and multi GPU and shared over here. So these two variants. So let me demonstrate you how you can load this model. Load this model in single GPU P100 and test it. Okay, so I have put forth the table of content like this. So what we are going to do is we install the necessary libraries. So what we need is latest transformers and Qwen vision language utils. Quanto you can use for quantization, but I'm using bfloat 16 right now, but you can try Quanto. I tried Quanto, but it doesn't require right now here. And when I tried Quanto 2-bit, no, on CPU it worked, but the output is not that great. So I'm not using Quanto right now, but we can use it to quantize it. Let's we also need accelerate, but I'm not using yeah, we are using it, accelerate. Okay, anyway, so we install the packages and then we import the required modules like OS torch. This is for Qwen model generation in the processor, and accelerate. So we use this to initialize empty weights for the model and for auto device map. This is very crucial when you have low GPU and you want to utilize all available resources to transfer your model onto the devices. and this is process vision info from VL utils, and this is image from display. Then we're gonna do optimize CUDA memory usage. So whatever the reserved by PyTorch, and if it is not necessary, so it kind of used for the model. So it basically do improve the memory efficiency for large models. That's the usage of setting this particular variable. Then what we want to do is we want to load the model. So load and configure the model. So this is from the Qwen definition, you usually load by default, but here what we gonna do is we're gonna do a little different. So we'll set first thing first, what we do is we init empty weights. So this is a method that we imported from accelerate, so it does import the model. And then we have two variants, one is 1 GPU setup and the 2 GPU setup or multi GPU setup. So what you can do basically is you can set for GPUs, this will be an integer, and CPU, MP, MPS and other, you can pass in the string like this. But for my GPU I want to use 7 GB of it, and for my CPU I want to use 15 GB of it. So for this device mapping, and if you have multiple GPUs, you can initialize that in the dictionary as integer 0, 1, 2, 3, and you can set the max memory that you want to put in. Then once you set this device map, and you can call the model from pre-trained using that device map. And for memory efficiency we are gonna use bfloat 16 precision. So that's it, like that's how you import the model, and it gonna download about 4.5 GB, and that will be loaded. So let me show you. So on my CPU, RAM has 2.2 GB, here 4.46 GB, on the disk I have 6.5 GB. So somehow it is managed to load the model and the processor. I have ran all this, but as you're running you can see most this is keep filling up from small value to the bigger value, and you can see once you load the model this will fills up, and this will be fluctuating as you're making progress over the course of execution. Then the processor, so by default you can pass, this is optional, but this actually makes it efficient to constrain on the input images. So based on your memory of GPU, you can set this to constrain the input sizes. That's what it does. So that's your processor. So once we have the model and processor, we gonna define the inputs. So the inputs does contain a structure, like so we want to pass the input image, so I'm passing it from any URL, and I'm setting this role user content is a list of dictionary, where first is type image and that image URL, and the next type is text, and the text describe this image, whatever the text that we want to pass. So this will be processed again using apply chat template of the processor. So the messages will go here, and we do process this as a text, and then we process vision vision info of the messages into image inputs and video inputs. All three together will go into the processor to create the final inputs to the model. Okay, so they will be pushed to the CUDA GPU, and then we are all set to generate the output. Here we are going to generate the outputs by passing the inputs and setting the max new tokens. So those many new tokens will be generated based on our input. So that's our expected output. Okay, so these are all the outputs that is generated by the model. But what we want to see is the new tokens that it has generated, right? So that's why out of these generated IDs, the out IDs, we want to get from the end of new input IDs. So length of this minus length of this is 128, that which is this. So that's what you get. The last 128 token IDs is what you get from this. This is generated ID streamed. So that will be passed to our bash decode. That's how you convert your token IDs to the readable text or vocabulary, right? So that's what the output text is. So let's print that and we can see. So the output generated is the image. So this is the image that we passed in, and this is what the description says. By the Qwen 2.5 VL model, the image depicts a serene and tranquil scene of a person sitting on a wooden dock at the edge of a calm lake. The dock extends into the water, creating a connection between the man and the vast expanse of the lake. The lake is surrounded by a misty mountainous landscape, adding a scene of depth and tranquility to the scene. The sky above is a gradient of colors, transitioning from a deep blue at the top to the lighter hue near the horizon, suggesting either sunrise or sunset. The reflection of the person and the surrounding of landscape is perfectly mirrored in the still water of the lake, enhancing the scene of peace, and that's where 128 tokens ends. But this is great, from this it model understood the scene and generated it. Though I don't see the person reflection, but I see clearly mirroring the mountains and the scenes, right? That's great. So that's about it. After many trials of putting this model into a single GPU in 16 GB, this is a final success that I got. So I wanted to share this to keep a record of it. Thank you for watching.